Pinhole leaks in plumbing pipes can be a frustrating problem, especially in homes located near railroad stations. There are several potential causes to consider, and while replacing the pipes might seem like the only solution, there are other mitigation strategies to explore. Firstly, electromagnetic interference, or EMI, can play a significant role. Railroad tracks often carry high-voltage electricity which generates electromagnetic fields. These fields can induce stray currents in plumbing pipes, leading to electrolysis and corrosion. The resulting corrosion can manifest as pinhole leaks in copper pipes. Secondly, stray currents themselves, regardless of EMI, can be a culprit. These currents can arise from defects in the electrical system or grounding of nearby structures. The stray currents can travel through the soil and into the plumbing system, causing corrosion and pinhole leaks as they interact with the metal pipes. Beyond these railroad-related influences, other factors can contribute to pinhole leaks. Chemical imbalances in the water supply, for example, can be a problem. High levels of chlorine or other aggressive chemicals can corrode pipes over time. Water hammer, which refers to sudden pressure surges in the plumbing system, can also cause pipes to vibrate and eventually develop leaks. Poor plumbing practices such as improper soldering or installation can create weak points in the pipes, making them more susceptible to leaks. In older homes, galvanized pipes may be present, and these are more prone to corrosion and pinhole formation than other materials. Now, let's discuss mitigation strategies to address the pinhole leak issue. One approach is to isolate the plumbing system. This involves installing insulating gaskets or dielectric unions between the plumbing system and any nearby electrical conductors. It is crucial to ensure proper bonding and grounding of the plumbing system to prevent stray currents from entering the pipes. Another important strategy is to control stray currents. This starts with investigating potential sources of stray currents, such as electrical faults or improper grounding in nearby buildings. Any identified defect should be addressed promptly to minimize current leakage. Consider installing grounding rods to provide an alternate path for stray currents, diverting them away from the plumbing system. Improving water quality is another key step. Test the water supply for chemical imbalances and adjust the treatment as needed to reduce corrosion. Installing water softeners or filters can remove excess chlorine or other harmful chemicals. In some cases, despite mitigation efforts, replacing corroded pipes becomes necessary, especially if significant corrosion has already occurred. When replacing pipes, consider using corrosion-resistant materials such as stainless steel or PX pipes, as these are more durable and less susceptible to corrosion than traditional copper or galvanized pipes. Regardless of the approach taken, regular inspection and maintenance are essential. Regularly inspect plumbing for any signs of leaks or corrosion. Address any issues promptly to prevent further damage and minimize the risk of pinhole leaks.